This video takes a look at the 5 organic reactions that you need to know in organic chemistry, starting with esterification. So if you have an esterification reaction, from naming, we know that esters are formed from alcohols and carboxylic acids, but how it will work is an OH from the carboxylic acid will come together with an H from the alcohol. When they're close enough together, they will react, forming water. And then this carbon now needs something to bond to, and this oxygen will need something to bond to. So they end up bonding to each other. It's actually over here. So that's our esterification reaction. So when we take a look at our first example here, propa-1-ol with ethanoic acid, I tend to like to write my carboxylic acid first. So I would write ethanoic acid with the OH group, and it would have one more carbon, which would have your hydrogens on it. And then this is reacting with propane-1-ol. So that would be 3 carbons in our chain, and on carbon 1 we would have that OH group, and then of course fill in your hydrogens. Then we would see that the OH will come together with the H from the alcohol, and that will form water. And then we would have that carboxylic acid that still has a double bond to oxygen, and we have another carbon here. And now since this carbon has lost this OH group, and this carbon here, the oxygen lost its hydrogen, they need something to bond to. So this oxygen is going to come and bond to the carbon. So we'll see that oxygen, and then we still have those 3 carbons on that oxygen as well, and we can fill in our hydrogens. So we can see that the ester was formed, we have that linkage, and we can move on to the next one. So the next type of organic reaction is combustion. With combustion reactions, you are doing what you're used to, right? You're going to have a hydrocarbon in the presence of oxygen, and it will always form carbon dioxide and water. So with this, what you want to start with is the empirical formula. And if you have to, draw it out to know how much you have. Unless you know the formulas, you can always use that. So if you have but-2-ene, so just drawing that out, and I would know I'd have 4 carbons, and then filling in your hydrogens, just so we know what we're dealing with. And we have this. So I drew this out just to recognize that I have the 4 carbons and a total of 8 hydrogens. I just want to double check. 3, 4. Yes, 8 hydrogens. So that's my empirical formula. And now I'm just doing what I'm used to, reacting it with oxygen, and combustion will always produce your carbon dioxide and water. And then we want to go ahead and balance it. So we'll need a few 4s to balance out the hydrogen and the carbon. And then we'll need, I believe it was a 6 in front of the oxygen to balance that out as well. So that's nice and easy as long as you remember to do your empirical formula. Now in an addition reaction, you are breaking a double bond by adding in a small molecule. So if I drew out my first alkene, I have pent-ene, so I want to just have my 5 carbons. My double bond is on carbon 1, so between 1 and 2. On carbon 2, you also have a methyl group. So we can fill in the rest with hydrogens, and then we're adding in hydrogen gas. And when we do that, we want to see that this double bond here is going to break. If this double bond breaks, then each of the carbons that the double bond was between can accept another atom, and that atom will be whatever you add in. So I would redraw my chain, 2, 3, 5. I still have my methyl group on carbon 2, but now all of the rest will be hydrogens. And the other part with addition reactions, you start with 2 reactants and you end up with just 1 product. So that's 2 ways to identify: 1, breaking the double bond, and then the second way, you just have 1 product. if you have an elimination reaction, elimination is in a sense the opposite of a addition reaction, because instead of breaking a double bond, you're going to form one. So this example with this molecule, I'm just going to redraw it so that it's in a straight chain, just because I think then it's a little easier to see, and I'm going to show all my hydrogens as well. So I do see I have the OH group on carbon 2, and then when an elimination reaction occurs, you are eliminating off of your molecule. So I'm going to look at my OH and see that when it comes close to hydrogen, it would want to form water. So we do have heat here. We know it's exothermic. We have a presence of a catalyst. So we will get water as a product. And then when the OH and H leave, each of these carbons now need something to bond to. So they are going to bond to each other, forming that double bond. And then you can fill in your hydrogens for the rest of it. That one had too many. So filling in your hydrogens. So then with elimination reactions, we want to remember that we're taking something off of our molecule. So we're just starting with one reactant, and you end up with two products, and a double bond is in one of them. Our last reaction is substitution, and substitution is when you are swapping hydrogen or a functional group to replace it by a different functional group. So with substitution reactions, you start with two reactants and you end with two products. So if we take a look at ethanol, you have your 2-carbon chain with an OH group on one of your carbons, and then you have HCl. So if we have HCl here, usually your functional groups is what we'll swap, but there could be some other possible reactions you can work out here. So if it is a substitution reaction and we're swapping there, then we'll have those 2 carbons, and then instead of that carbon being attached to the alcohol, it's now going to be attached to the Cl. And then when OH comes over from swapping with the Cl with that hydrogen, it will just form water. So those are our 5 types of reactions. So just going through that one more time. Combustion, what you're used to, that hydrocarbon in the presence of oxygen forming carbon dioxide and water. Addition reaction is when you have a double bond to start and you're adding on a small molecule, and you break that double bond and form just one product. Elimination is when you start with one reactant and you are eliminating a small molecule off of your reactant. So a double bond forms and a small molecule. So the opposite of addition. Substitution, you have 2 reactants and you will have 2 products. And within your reaction, just something swap places. And then the last one, esterfication, you have a carboxylic acid being added to an alcohol, and that will form your ester. And water. So those are our reactions that we want to be familiar with. And then there is one more with polymerization, but polymerization is addition reactions or esterification reactions, or condensation would be another word for it. But we can take a look at that a different day. But those are the first 5 you want to start with. And if this was helpful, please subscribe. If there's any other video I can do for you, let me know. But you can always check out my website right here with a breakup of all the videos I have on specific topics in chemistry. Thank you for watching.